Good morning. Today we will see the next topic, that is array frequency shift keying. So first of all we will see what is meant by frequency shift keying. So the frequency shift keying is the modulation technique in which the frequency of carrier changes according to the input data or according to the input binary data. So this is known as frequency shift keying. So already we have seen the binary frequency shift keying. So here we have to see the array frequency shift keying. In array frequency shift keying, depending upon different symbols, the array FSK has different frequencies in their output. Okay, so here this block diagram shows the array FSK transmitter. So first of all we have to apply, that is binary data, that is B of t, as input data to the serial to parallel converter. So we will see the operation of that Ary FSK transmitter with the help of this block diagram. So the input signal V of t is applied to the serial to parallel converter, and here, that is clock of duration Ts is equal to n into Tb, means symbol duration Ts is equal to small n into Tb. Tb is the time duration of beat and n is the number of bits. Okay, is applied to the serial to parallel converter, then DAC, and then sinusoidal carrier and frequency modulator. Okay, so with the help of that serial to parallel converter, first of all convert the serial data into the parallel data, that is B1 to Bn. If the n is equal to 8, then B1 to B2, B3, B4 up to the B8. Okay, then that parallel digital data is applied to the digital to analog converter. Okay, so here DAC, that is digital to analog converter, is used to convert the 8-bit digital input data into the staircase signal, and which has m, that is m is equal to 8 number of different level, that is varies from 000 to 111. Okay, so this is the use of DAC. DAC is the digital to analog converter, which will convert the digital or the parallel digital data into the staircase signal, and the output of DAC, that is the staircase signal, is applied to the sinusoidal carrier and frequency modulator. Then that frequency modulator is used to produce unique frequency output based on input symbol. When the input changes from one symbol to another symbol, frequency also changes from the one frequency to other frequency. And here this here shown in the voltage control oscillator, that is input signal is, that is 000, then 001, 010, like that up to the 111, and it is the input signal. So according to that input symbol, the frequency changes from one frequency to another. For example, if the input symbol is 000, then the frequency for the output is will be F1. If the input symbol is will be 001, then frequency of output will be F2 up to the F8. Okay, so this is the use of frequency modulator. In this way we will get the output of FSK, that is S of t is equal to under root 2 ps cos omega ct plus m of t into ohm. So equation of S of t for the m is equal to 8 is given by under root 2 ps in curly bracket cos omega 1 t plus cos omega 2 t plus dot 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 plus cos omega 8 t. Okay, so we will see the array receiver, array FSK receiver, that is non-coherent receiver. So the output of array FSK, that is F1 to F8 frequencies of that is output of array FSK. It will be changes from one frequency to other frequency, is applied as input signal for the array FSK receiver, that is S of t. Okay, so here in a block diagram of array FSK receiver, first is we have to use the different bandpass filter for the different frequencies for F1 to F8. Then we have to use the envelope detector, then we have to use the select largest output device, that is adder, then analog to digital converter, and then parallel to serial converter to get the original signal back at the receiver of array FSK. Okay, so first of all we will see the operation one by one. So the output of array FSK transmitter, that is different frequencies will be applied as input to the Ary FSK receiver. So first of all, we will see what is the use of band pass filter. So the band pass filter passes the specific band of frequencies and block all other frequencies. Suppose you will consider band pass filter 1. Band pass filter 1, that will pass the frequency f1 and it will block the other frequency, that is f2, f3, f2 up to the f8. Same as band pass filter 2 will be only pass the frequency f2 and it will block other frequencies, like that. Then output of different band pass filter is applied as input to the envelope detector, and here also we have to use the envelope detector for the different when if envelope detector 1 is take the output from band pass filter 1, and envelope detector consists of a rectifier and filter circuit, so it will convert that analog signal to the DC signal. Okay, so the output of envelope detector 1 will be V1, output of envelope detector 2 will be V2, like that. The output of envelope detector number 8 or M number, that is VM. Okay, so the different envelope detector output, that is V1, V2, V3 up to the, if you consider n is equal to 8, then up to the V8, then this is applied as input signal to the select largest output device, that is the adder. Means that select output largest output device, that is adder. The function of this device is to add the output of each envelope detector, that is DC output, and build the staircase signal. It will add all the output of envelope detector and it will build the staircase output signal, and the output of this select largest output device, that is adder, will be given as input signal to the analog to digital converter. Then that analog to digital converter signal convert that staircase signal into the digital signal, and that digital signal in the form of B1, B2, B3 up to the Bn, that is parallel form. So again we have to convert that parallel digital signal into the serial converter or serial form. So that's why we have to use the parallel to serial converter, so that B1, B2, B3, B8, that parallel digital signal is applied to the parallel to serial converter, and with the help of that parallel to serial converter we will get the output in the serial form, that is B1, B2, B3, B4 up to the B8. So the original signal will be get back at the output of a receiver of Ary FSK. Okay, so in this way we will get the original signal from the encoded signal of Ary FSK. Okay, thank you.